One of the simplest ways to tell the story is that we kept building incrementally larger and larger robots until we landed on trucks.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. All roads lead to the future, and no one knows it better than today's guest, CTO and co-founder of Embark, Brandon Moak. Brandon joined us for a live Industry Tech Days keynote session last week, and we're bringing that session here to the lobby for you. You can also catch the video version on allaboutscircuits.com on the Industry Tech Days 2021 page, and let's jump over to the keynote. Autonomous vehicles used to be a sci-fi trope, but now it's a multi-billion-dollar investment for automotive companies and mobility as a service providers around the world. And these investments are starting to pay off. One of the most addressable segments of self-driving isn't passenger cars, it's self-driving semi-trucks. That's why Brandon Moak and Alex Rodrigues co-founded Embark, a company that aims to address driver shortages, safety issues, and supply chain challenges in one self-driving swoop. Today, I'm joined live by Brandon Moak, the CTO and co-founder of Embark, a $5 billion startup poised to revolutionize the trucking industry. Brandon, thank you so much for being here. Can you tell us a little bit about your background and how you spend your time?
Thanks, Daniel. Yeah, I'm Brandon Moak. I'm the CTO and one of the co-founders of Embark Trucks, and we're working to build the world's first automated self-driving truck.
So what entails an automated self-driving truck? What does that mean?
Yeah, great question. What we are set out to build is this software that can perceive the world using a bunch of sensors, so radars, lidars, cameras. And what we do is we collect all of this information around the vehicle, we process it on board our trucks to reconstruct this 3D scene of what the world looks like around us. At that point, then we have to figure out where to go. So as a truck, what you have to do is move freight from point A to point B. So we sort of have this notion of our routing layer. How do we go from our one hub to another hub? And then we have to plan around what we see in the world. So all the other actors in the environment, like pedestrians on the side of the road, vehicles on the road. And then after that, we have to send controls to the truck itself. So physically interacting with hardware. So our technology stack is quite diverse in nature, which makes it one of the more interesting problems to work on and keeps me excited. But yeah, that's sort of a lot of the problems that we focus on here at Embark is really just the perception, motion planning, and control of these vehicles. At the end of the day, Embark, we want to build, we want to be a software as a service company, sort of this virtual driver, as you will, where we want to be the ones driving the vehicles, but we'll have existing OEMs and partners actually do the manufacturing of vehicles.
So instead of having your own line of like Embark semi-trucks, you want to almost be like a part of the tech layer that makes autonomous trucking a thing or shipping a thing.
That is correct, yeah.
Interesting. So how does software as a service work in that sort of environment? Is it per day or how do you like quantify that?
Yeah, it'll actually be per mile, and which is how the existing trucking industry works right now. Is you charge per mile to move freight across America. So we'll actually fit pretty cleanly into that model that exists already.
Interesting. And I've seen that in other parts of trucking with like tires and maintenance and that sort of thing. So do you think that is well understood by the industry, or is it kind of a new thing that people are maybe uncomfortable with?
I think this specific idea probably is, at least they're accustomed to that idea of charging per mile, but I think maybe as you're alluding to here, there's a lot of nuance and detail when it comes to how you actually operationalize a self-driving truck. And, you know, we have to spend a significant amount of time with shippers, with equipment manufacturers to really tell the Embark story and paint the vision for how we think we're actually going to deploy these vehicles in the real world, and what are the new operational constraints that may or may not exist as a result. So we do have a pretty heavy hand in educating the marketplace so that we can bring our technology to life.
Now, I want to geek out on the tech a little bit. So
Sure.
You have a background in mechatronics. Can you talk about how you got into robotics and why that's something that is exciting and interesting for you?
Yeah, I think growing up, I had always had a little bit of a knack for engineering. I don't know if there was a specific light bulb moment for me, but um, yeah, I when reflecting, I always think about times where um, I would get super excited about building projects to build these toothpick bridges, or um, playing with circuits at a young age, or even learning to code the summer before college. Really just throwing myself into it. I think mechatronics to me at Waterloo was really exciting because it very much seemed like the future of where technology was going, higher and higher levels of automation. And I knew I just wanted to sort of be a part of that atmosphere. And I didn't really have a specific outcome in mind, but I knew that the space itself was really exciting.
This keynote session is brought to you by EA Electro-Automatic, the leader in bidirectional DC programmable power supplies and regenerative DC electronic loads. EA's sustainable test solutions are enabling manufacturing companies to overcome demanding test challenges, as well as work towards their goal of climate neutral certification. And now back to our interview with Brandon Moak, CTO of Embark. In college, I don't know if I would tinkered is a safe word, but you built like an autonomous golf cart sort of system. Can you walk us through how that got started and why you went after that?
Yeah, Alex and I, my co-founder Alex, we had become really good friends through working on a number of projects together, ranging from like spinning LED displays to smaller line following robots. And maybe one of the simplest ways to tell the story is that we kept building incrementally larger and larger robots until we landed on trucks. But in reality, I think we had seen what a lot of the early DARPA and Google projects had looked like. And almost naively, we started day in, day out debating, how could we do that? Could we do this as students? Until one day we sort of just said, let's do it. Let's pull the trigger. And we had some semblance of a plan of how we could approach building this technology. But I think, for better or worse, we didn't know what we were getting into. But I think we jumped into it, and it was a lot of fun.
So did you just have a golf cart sitting in your garage and you're like, hey, let's just automate this? Or how did that happen?
We didn't. No, we actually started off with this like very small scale Lego robot that we assembled over the course of a weekend, and we started to program, and we had this like Xbox Connect style sensor, and we're like, well, this kind of looks like the LiDAR that we want to buy, and like, can we start to make some levels of autonomy on this thing? And then we're like, okay, well, we this kind of works. We ran a couple tests, and we're like, what, let's just go for it. So we found a used golf cart that we could buy for pretty cheap. We had a couple connections through the university and some personal connections that allowed us to get access to some of the higher grade sensors, like an inertial measurement unit, a high accuracy GPS system, and a LiDAR. And because Waterloo is really big about entrepreneurship, and in the earliest days, although we were building this project for fun primarily, we pitched it as a business so that we could get grants and win pitch competitions. So on the outside, it was this grand old business idea, but on the inside, it was really all about just building something that was cool. So we were able to fund the effort through winning some pitch competitions. And that really just set us up for a good 4 to 6 week build cycle to build what became Canada's first self-driving vehicle.
That's so great. Tell us kind of, you funded it. What are you putting on this to make it actually viable and feasible as Canada's first self-driving vehicle?
Yeah, it was stripped down to its basic parts. It was a very simple and I would say almost brittle system. In the earliest days, you can't really build a self-driving vehicle in 6 weeks, as we've learned, unfortunately. But yeah, sort of the shape of the solution was one, focusing on the vehicle platform. What do you need? You need the ability to control the vehicle, so steering, throttle, brakes. We had jerry-rigged, and this is where some of Alex's robotics competition experience really came in, but we kind of reverse engineered the vehicle, jerry rigged a few mounts to put some motors on the steering wheel. We reverse engineered the electrical system on the throttle itself so we could give it some gas, and then we had a string pull the brake. And then, so that was kind of the vehicle base platform, and put that together over the course of a couple weeks. On top of that, you have an embedded system, and that's really just kind of connecting all of these electronics from power all the way through the actuation of these various systems. And then we just had this MSI laptop that served as kind of the brain of the system, and that connected to our higher level sensing and compute stack. So that's where we fed in the GPS system, that's where we fed in the LiDAR. And we wrote some pretty basic algorithms to detect out of the LiDAR data, is there something in front of us? It was kind of like a very binary system, almost like the intent, the goal was to have this vehicle, we would drive it in a circle and then it would follow that path again. And if anything pops in front of it, it would just stop. And that was kind of the limitations of that system, but capable enough to, to be the first vehicle. So in that higher level system, we wrote a few path planning algorithms, based off the GPS system, and then the LiDAR processing algorithms to detect if there's anything in front of us. And you kind of plug all these things together, and then you get the first self-driving vehicle. And it was really cool. We worked with the University of Waterloo to drive it around what was called the Ring Road. So it was the road that kind of spanned and went around the edge of the whole campus. And that was the first time that we actually drove it on a public road, and that was really cool.
And then at some point along the way, did it occur to you or like hit you that we have to actually put people on this? How can you describe that first actual test and kind of what was going through your brain at that point?
Yeah, I think a little bit. So we were very thoughtful in the design of, what were the fallback and the failure modes at the end of the day. We knew that when we'd be operating this vehicle, 95% of the time we would do it with a safety driver, one of us in the vehicles, because we knew the design, we knew the system. And if there's a person in the vehicle, you have some level of control. So we put emergency stops around the vehicle, where if you would just press this button, it would cut off all power to actuation and compute, and then it would just return back to a normal vehicle. So that was kind of one of the failure modes, or the safety fallback modes. And then we only drove it fully autonomously a very limited set of times, and those were in very controlled conditions. And we had wireless remote e-stops and stuff like that. So from the beginning, we did intend for it to be driving autonomously, and we had thought through some of the safety case around it. But at the same time, we knew that this wasn't going to be a product that we would deploy and just sort of let it go on its own for months on end. So we knew that there would be a level of hand-holding that we could afford in this.
But now you are. Now that's your end goal, is to wash your hands and say, go be free on the roads. What made that shift for you from passenger to like a business to business sort of enterprise? And what actually triggered you to say, hey, this is something we could actually do and pull off, and this is somewhere we can make an impact on the future? Can you talk through that shift from golf cart to semi?
So after we made the very first golf cart prototype, we had gotten a lot of media attention, specifically in the Canadian news networks, because it was a really interesting project that we had been working on. At that time, like I mentioned before, we were sort of pitching this as a business, but doing it for fun. But it just sort of started to become a little bit more real. There weren't a lot of people at that time, back in 2015, who had built a full stack self-driving vehicle, even though it was very primitive in its form. And Waterloo's has deep roots in the entrepreneurship network, and a few people had approached us and said, hey, you guys should go to Y Combinator, the startup accelerator in Silicon Valley. And we were a little bit surprised by that recommendation, but at the same time really excited by it. And so we applied to that program, we got in, and YC was all about how do you take what you have now and build it into a business, right? We don't care that it's cool technology, but you got to make something that people want. And how do you do that? So the whole program there was focused on how do we take what we have as a vehicle platform and prove that it can be commercialized. And we learned a lot through that journey. We took our shuttle, we iterated on the design once over the course of 3 months to make it look a lot more professional, it be a little bit more robust in the way it thinks and sees about the world. And we demoed it at 6 to 8 different university campuses in California. These were kind of like 2-day demos where we would sort of map out one region of the campus. We'd drive between 2 points and shuttle students between, maybe their classes in the center of campus. And this was really cool because it was the first time we really put the general public in our vehicles. And again, we still had safety drivers. But it was really cool to see the moment where everybody was like, self-driving vehicles, like they're real and they're coming. And that was really cool. You could see like the level of excitement on their face. And then 5 seconds later, they were looking down at their phone as if nothing interesting had ever happened whatsoever. But we learned a lot of like really important things in that moment. And I think it was really crucial for us to kind of incrementally build through this, because I think we learned what would become the values of Embark when we finally shut down the shuttle project and started on trucks, which was first and foremost going to different university campuses. They all looked different, which posed different technology problems, and that was really interesting. I think we found so sometimes they were very idealistic. We were driving on paved paths, not a lot of pedestrians walking around. Other times we were in Sacramento State, and they have, I think, like one of every tree in the world on their campus, and they're overhanging the walkways and the roads, and you have complete occlusion on GPS, and that was interesting. Then our technology like struggled to work there, and so kind of the takeaway from that was, very much so like problem you're trying to solve dictates the solution you have to build, and that's the way it has to be. And I think a lot of the robotics industry at times is a little bit more idealistic than that, but very much, the scope of your problem, changes the complexity of what you have to build. And that was a really neat and interesting takeaway, which meant that the more constrained your problem is, the more solvable it becomes. The other thing we learned at the same time was that students were perfectly capable and efficient at walking themselves to class. And they had no money to pay for a shuttle service, nor did universities want to really invest in this infrastructure. We were just really nice marketing material for them at the time. And so just the business prospect didn't make sense. And so I think going through Y Combinator, it really allowed us to just refine and learn like what's really important when trying to build a technology business like this, and its scope of problem and impact of solution at the end of the day. And so kind of when we took a step back to look at where do we go next, we had a lot of momentum because we were still able to build this technology, but it just wasn't going to be in the shuttle space. We looked at the mining facilities out in Australia. We looked at the small sidewalk robots for delivery, but we ultimately landed on trucks because it really did. We could do a really good job of optimizing for those two key values, which was, let's constrain the problem. Let's have our system go hub to hub. Let's not deal with the intricacies of driving in the city streets because it's really complex there, but let's just primarily focus on highway driving in the inner city travel. And that kind of checks off number one, right? That's obviously a simpler solution than the downtown streets of San Francisco, where you have a lot of crazy stuff happening. And then you kind of look at the trucking industry, and at a first glance, it's massive. It's $700 to $800 billion, and that's really exciting. But then you start to peel back the layers, and you realize that it's an industry that's under a lot of stress. We're already 100,000 truck drivers short, which means that if you and I were to become truck drivers, we'd have jobs immediately, and you can't say that about every single industry. But that's really interesting. That's a trend that's been growing for the last decade and a half, and I think probably with coronavirus and everything else, the industry is under more and more pressure. And then you think about the kind of social impact that we can have when we deliver this technology on roads. And you look at the fact that 44,000 people die annually on US roads. And if we make these systems safer, we can save lives. And that's really compelling. So you kind of put all of these pieces together. You say, the arc of AI and automation is trending in this direction, and it's an inevitability, at least in my opinion. But then you focus in on an industry where it matters and where there's a need. And I think you have a recipe for success. And we've kind of focused on that since day one. And that's a little bit of the story there.
hardware is such an essential part of an autonomous system. Can you talk through like the sensor suite that is it, camera, computer vision? Is it LiDAR? Is it a combination? You mentioned maybe like thermal cameras.
Yeah, so we at Embark, we take a very pragmatic attitude when it comes to sensing. Each sensor modality has something unique that it brings to the table. So we're very excited about using radars, LiDARs, cameras, thermal cameras, GPS systems, anything we can really get our hands on, because the environment does have a lot of variation at the end of the day. And one of the awesome things about working on trucks rather than consumer vehicles is that we just have a lot of, we don't have the same space and cost constraints that a Tesla might have. So we can afford to put super expensive sensors, at least in the near term, on our vehicles because the economics will still work out. So the radars are really interesting technology because they're really robust to acclimate weather given how they're designed, and they can see really far and then give you the speed of the objects around you. The LiDARs themselves give you a really nice, rich, dense picture in 3D of what the world looks like. And then cameras obviously just has so much rich visual detail which helps you classify, like, is that a red car? Is that a motorcycle? All that type of thing. And you sort of, weigh the trade-offs and balance them in different scenarios. So in a fog scenario, your radars and your LiDARs will do a lot better. On nice, clear days, your cameras can see really, really far, and you can get all of this classification information. So at different times, our technology stack is balancing the information, and we kind of fuse it all together in this one part of our stack to reconstruct the scene around us.
So when you work with OEMs, do you have like a checklist of sensors that are essential to make it work? Or is it kind of a, give us the data you have and we'll crunch the data?
Yeah, it's a little bit of a trade-off. I think the industry, the sensing industry, is, it takes a long time to develop a new sensing kit. And so when you start working on self-driving vehicles, you have what's available to you at the time, which is sensors that have been built for ADAS systems, maybe some sensors that have been used in defense or aerospace. You kind of slap together a system based off of that. But what we've been seeing over the last 5 to 6 years is companies really starting to invest in sensing kits for automated vehicles. So we end up being a part of the conversation about talking about, what do we need from a specification perspective? Is it range? Is it density? Is it signal to noise ratio? What are all these things that matter? So, it very much becomes a negotiation with the vendors, but also at the same time, we're making improvements to our software to be able to process this data. And so that sort of happens in tandem.
That makes sense. Yeah, I'm thinking through ways to throw my thermal camera onto my car and see if I can start automating better. So I want to put you head to head with Elon Musk here. He was on record saying LiDAR is out and computer vision is in. Any comments on that?
I get asked this question a lot. So maybe the first thing I'll say is maybe in the limit where AI trends, we can build a self-driving vehicle on higher level automated systems solely off of cameras. What I'll say is that the data that you get from LiDARs, from radars, et cetera, they're just extremely rich in nature. And if you're thinking about building a safety critical, multimodality, redundant system that you want to deploy in the real world in the near term, there's absolutely no reason to not use LiDAR and radar. If I'm going to be a little bit direct, I think Elon Musk needs to sell cars and needs to sell them to consumers, and he wants them to be self-driving eventually. And there's no way you can put a LiDAR on a car today and make that make sense for the consumer. So I think they have different constraints on their problem, which I think kind of comes back to why I think trucking in the way we're solving this problem makes a lot of sense, because we don't have those constraints, which allows us to build technology that can see and understand the world a lot better.
When it comes to testing, I imagine the last 18 to 24 months have been challenging to say the least. We have a parts,
Right.
hardware shortage going on. We have COVID happening that is, limiting how many people can be in a vehicle together. Can you walk through some of the roadblocks, no pun intended, that you've run into and how you've gotten through those in the last 18 months?
Yeah. First and foremost, I guess with COVID, like most businesses, business just came to a halt overnight, and that was surprising and a little bit of a shock to our system. And for us, in the earlier days, we relied a lot on road testing because it's just such a good, rich environment to test your software, and it's very realistic. But overnight, we lost the ability to do that, and that it was an important piece of our development cycle. So we sort of sat there with, a bunch of truck drivers that didn't have anything to do, and a bunch of operators who sit in the truck and, make annotations of what they see while the truck is driving. And then we had a bunch of engineers who needed to test software. And so we kind of took a step back and said, well, given the resources that we have available, what can we do? And we sort of doubled down on our investment in simulation to be able to test our systems offline. And at the same time, we leveraged the workforce that we did have. So when developing machine learning algorithms, a huge component of it is just labeling the data and kind of taking a human eye to the problem and saying, this is that, this was labeled wrong. So we actually leveraged the part of our workforce, the truck drivers and the operators, to do a bunch of labeling tasks for us. And fortunately, and this is something that we're really proud of as a team, is that we were able to retain everybody on staff because we were able to retask everybody in that capacity. And then once we learned more about the situation, we could be a little bit more precise about protocols and when we could have people in vehicles and ventilation requirements and masking. And it was a many months long project to kind of get our wheels underneath us again and start testing. I think the chip shortage has been really interesting. We haven't directly been impacted by that, but I know a lot of our vendors have. Very early on, once we started to hear about it, we started to risk buy a bunch of parts so that we would have just enough stock to keep building our fleet and testing in the way we needed to. So we've been, at least up to date, fairly isolated from that issue.
Some fantastic foresight on your and the company's part then. Congratulations.
Yeah.
I know not everyone listening is in that same boat. So
right.
I'm sure that was a big win for you. Are there any moments that come to mind? Can you share a moment that was like, maybe you thought, what are we doing? This is over. That went terribly. And then are there any moments where you realize like, hey, this is a viable solution that's going to like drive off into the future?
Yeah, I think development ends up being quite incremental in nature. And what I'll say about building a company and new technology is that you just always need a persistent level of optimism. So I think there is always setbacks that you see, like maybe you've built this new planning architecture that gives you so much flexibility about being able to plan new paths and reason about them, but the solution itself ends up being a little bit too complex, and you sort of overdid it, and your upstream modules didn't have enough precision to support it. I think in the design process, there's been a few instances like that. I don't think I can specifically think about anything that was like, no, there's no way forward, because there's always something better to do. There's always another idea. In terms of moments that are a little bit more forward-looking and exciting, I think there's many of them. Anytime that the vehicle did a first, I would recall on. So the very first time we had our truck on the test track, controlling it with the steering wheel, the throttle, and the brakes. We weren't sure we were going to be able to do it on this platform because it was just a lot more complex. And that was a moment of awesome, we've got a vehicle platform that we can test this, we can do it. The very first time we had our system driving on a road and just doing lane keep assist and ADAS similar to a Tesla system, that was we've done the very first set of basics, and that's really exciting. The very first time our truck drove from Los Angeles all the way to Phoenix without the need for a human intervention, that was a huge moment for the team, where I was able to drive hundreds of miles without the need for a human. And kind of just over time, seeing the accumulation of those milestones, I think ends up being really inspiring.
So did college you, what would college you say to today you, who has launched as a public company with NASDAQ, a autonomous driving company?
I think you'd say that's surprising. Yeah, I think, in college, I always knew that if the right opportunity came up, I'd drop out and go for it. But it wasn't very clear. I wasn't somebody who sort of sat back and was always just looking for an idea and an excuse to go down this path. I think I was fortunate in that, one thing just sort of led to another, and we followed the path, and it sort of led to this.
So do you feel, how much do you feel that it's something that fell into your lap, but at the same time, you've put a ton of time and effort, and really it's a pretty risky thing to drop out of college to go after this. What was going through your brain when, like, you told maybe your parents or your friends, like, yeah, I'm out, I'm going to go do this thing?
Yeah, I think they all thought we were a little bit crazy just because the project itself was really ambitious. I think what was going through our minds at the time was we understood that this was a short window. Google, Cruise at the time were starting to get off the ground in their projects. We thought we could be competitive in this space, and we knew that if we waited another 2 to 3 years, that the opportunity would disappear. And so we sort of thought of this as like, we've got to go now or there's no other opportunity. So in terms of falling on our laps, I think, a lot of that just comes down to timing, and we were at the right place, right time, built the right thing. But I think the way we were thinking about the risk of it all was, we missed this opportunity, it's never going to come again. Versus, I can probably still go back to Waterloo and get a degree. They'll probably let me in. That's still there for me. But yeah, I remember, telling my parents. They were a little bit hesitant, but still supportive at the end of the day. So that was helpful.
Did you see it as I'm going to go take on the Googles and the Teslas of the world, or was it more of a, like, we'll just kind of see where this project goes?
I think it was like, I think we just had a little bit of an understanding that, big companies were going to focus on big challenges, and big challenges are really hard. And if we're going to be competitive, we're going to be extremely strategic and precise. And so in the shuttle space, we're just going to capitalize on the low speed shuttle market, and that'll be how we build a sustainable business. And in trucking, it was the same thing. So we didn't think for a second that we could beat them head on 1-to-1 in the earliest days, but we thought that if we were a little bit more thoughtful than them, that we could. And that was kind of the intuition. And I think we still kind of stand by those values, where you see a lot of big companies still working on the bigger problems, and we've been moving very quickly on the more focused challenges.
You mentioned that when you started, you didn't think you could take them on. Do you think you can take them on now?
I think so. I think with our recent transaction to go public, and funding the business with the amount of capital that we have here, and just reflecting on the core team of technologists that we do have, I certainly think we can compete, and I'm excited to.
As you talk about the big picture, one of the things that often gets overlooked or tacked on as kind of an afterthought is security. And I think that's maybe a theme that the automotive industry doesn't want to talk about too much in the world today. But can you talk about what sort of security measures have to be put in place for a system like this? Because it seems like a big
you're right.
concern.
And we sort of think of safety in conjunction, or security in conjunction with our safety story. Because at the end of the day, a compromise of our vehicle can have very real and very detrimental outcomes to the business, to the environment, to the people that are on the road. So kind of in the design process, that needs to be thought of up front. So, at a high level, we hold ourselves to using industry best practices for securing our kind of core infrastructure and communications with the vehicle, like including network-defined security, traffic isolation, encrypting our data, rotating secrets, all that fun stuff. On the hardware side, we're pretty thoughtful about segmenting the different components of our compute stack. So we have a primary compute that is kind of, we call it the brain of our system, the driver of our system, where its primary responsibility is to see, understand the world, and plan within it. but we also have backup compute stacks, and the backup compute stacks are isolated from the network in more rigorous ways. And so if the first compute stack is ever compromised, the backup system is able to take over and pull over the vehicle. And so we think about some of these problems through the lens of both safety and security to make sure that our architecture can be robust to compromises, in addition to just having best practices to begin with to mitigate the risk of having a compromise in the first place.
Okay. Can you touch a little more on the importance of this being a near perfect system? So you mentioned earlier traffic fatalities is a pretty high number every year. I think it was like 45,000, something like that. One autonomous driving fatality will make more headlines than 100, more normal. I don't ever want to normalize traffic.
All 44,000 of them. Yeah.
Yeah. Can you talk through like what is the bar like, and how safe does it have to be? How much incrementally better than a human driver does this system have to be?
Yeah, I think the baseline is, what we say internally, at a very minimum, that we can't be adding any additional risk onto roads, right? And so I think in some ways it would be acceptable to deploy a system that is equally safe as a human. I think that in conjunction with a development roadmap that we'll know that our systems will always be getting better. So I think the very, very minimum bar is human level of safety, and provably so. But as a company, we'll strive to be 2x, 10x better, especially in the limit as we deploy these systems. And we know we can be, because robots don't get tired the same way humans do. And so once we build a system and a solution that we know works, we can have a lot of confidence in that.
What about trucks running low on gas? So you do hub to hub. Is it like within a gas tank range? But you mentioned, the company's mentioned you're I believe the first to go coast to coast autonomously. Obviously, that's not a single tank of gas. What if I need like chains in the winter? I live in Colorado, and there's always these signs, trucks must carry chains. How do you handle those nuances, or is that out of scope?
Yeah, well, the gas tank question is my favorite question, because you can actually just buy gas tanks that are big enough to house 50, 60 hours of gasoline. And so what we do is we refuel the trucks on the endpoints, and you can go all the way across the country on one tank, which is really good and super exciting. So we don't have to handle the nuance of any robotic interactions at your diesel stations, which is good. In terms of snow and whatnot, I think automated systems will be really good in well-defined, well-understood areas. And so when you look at our rollout plan, very much we're focused on the southern border of America first, where you don't actually have snow. There's very limited rain and inclement weather. And then as we expand our technology capability, we'll start moving north. And since we're this B2B application versus business to consumer, we have all of these operational controls that are really interesting. So we can just say that, we're not going to service roads that go through the north of Tahoe, where you're going to have to put snow tires on. And if, a snowstorm comes up overnight in the middle of a trip, then you can just pull over your vehicle and leave the load on the side of the road until the storm passes. Those aren't the sort of things that you can do in a taxi setting, right? You're taking somebody to the airport and, you pull over and wait for the rain to pass. You're not taking a self-driving vehicle to the airport ever again. But with freight, we just have different operational constraints. So I think the model still holds up in cases where we have to pull over the vehicle and wait. And then as the technology gets better, maybe we'll never handle the tire chain case until we have tires that can support it. But I think we'll be able to do a lot in snow driving once we really dig our teeth into that problem.
What does a shipping hub look like? So I was at a restaurant with a friend the other day, and I saw this big semi truck, trying to back this trailer down an alley. In a shipping hub, is your goal just to pick it up, hop on the highway, exit the highway, and stop, and then a driver will come, dock it where it needs to be docked?
Yeah, that's essentially it. So this model in the trucking industry today, this is called a drop and hook maneuver, where at a high level, you will have a human driving the freight into the yard. They'll drop off the trailer, and then we'll have one of our automated trucks pick up that freight. So at the yard itself, It'll have a yard technician who's servicing the vehicles, doing the pre and post trip inspections. Almost like you think about you can almost think about these hubs as like airports where we're sending off and we're landing these trucks. So there's going to be some on-site staff that does all the pre and post trip stuff. They'll line up the truck, and then remotely we'll say go, and then the truck will leave the yard and get onto the highway, and then on the other end it'll kind of reverse the operation. So it'll park itself, the yard technician will maneuver the trucks, the human driver will take that trailer and take it to its destination.
Okay. I know we're almost out of time. At what point do you look at what you've created as a company and say, we've made it, we're here? Are you there yet? Is there a future state you're working towards?
Yeah, so our plans have us in 2024 starting to commercialize the technology. So that means we're actually running trucks without humans in the vehicle. I think that's probably one point in time when we'll say we've made it as a company. To get there, we have to kind of compose what we call the safety case, which is essentially our story on how we develop, test, and validate that our software is capable at the level that we expect it to be. And we understand that we're not going to be putting the general public at risk. So a lot of work needs to go into designing that safety case and ultimately validating that our system as a whole is ready to go. So I think that's going to be part one to we've made it. I think, beyond that, deploying our system in tens of thousands, hundreds of thousands of trucks, those will be really exciting moments to come as well.
So as we wrap up, if you could take all of Embark's budget and knowledge and experience and build something completely different just for fun, didn't have to worry about like the business case and the stock IPO price, that sort of thing, is there anything just for fun you'd say, hey, this would be a really cool side project or thing to go after?
Yeah, I think there's a lot of things I build. One thing that I've always wanted to do is to kind of go back to the roots of the golf cart days. And I don't even know if we could build this yet, but build a self-driving golf cart that can also golf itself. So you can have a fully autonomous system that's doing the full thing, driving, golfing, and all that. So maybe one day we'll get to that.
Brandon, it's been great having you. Thanks for being here, and I'll keep an eye out for your trucks on the road. Thanks again to Electro Automatic for sponsoring today's keynote, and thanks for joining me today in the lobby. I'm your host, Daniel Bogdanoff. If you want to watch the keynotes or one of the 50 other live sessions from Industry Tech Days 2021 last week, we saved them for you, so you can go watch them on demand on allaboutscircuits.com. Next time, we're joined by Dr. Jeffrey Welser, IBM's Vice President of Exploratory Science and University Partnerships, to talk about IBM Watson, quantum computing, and more.